Welcome to Precalculus Concept 16C, identifying vertical asymptotes, and we're talking about rational functions and their graphs. We have 3 boxes to cover, so here is box 1. Let's talk a little bit about what a vertical asymptote is. So I have 2 graphs for you, 2 different rational functions. The one here on the left, I've drawn in the vertical asymptote. It's this blue line right here. And it's over the line x equals 5. This will be the equation x equals 5. So what is a vertical asymptote? Well, a vertical asymptote is a line that kind of divides the graph into 2 parts here on the left and the right. And the idea is kind of like as our x values get closer and closer and closer to that vertical asymptote, our function, which is the graph of course, starts to behave more and more and more like that particular line, or shoots down to infinity as we were approaching from the left. Likewise, on the right-hand side, if I approach from the right, the function kind of shoots up to infinity, so the closer and closer and closer I get to the vertical asymptote, the more and more and more the function behaves like a vertical line. Now over here in graph number 2, in this one, the vertical asymptote here is the line x equals -3. Most of the time, you're not going to have the vertical asymptote drawn in. You're going to have to identify it from a graph. So you want to look for where the function, or where the graph is kind of shooting up off into infinity or down to negative infinity. And that's basically what a vertical asymptote is. It's a vertical line that the function tends to behave like for really close values close to it. Okay, here's box number 2. We are going to learn how to identify a vertical asymptote from a rational function. I have 3 little mini examples here for you. The first one says f of x is equal to 3 over x plus 2. I'm going to go ahead and write the domain down. The domain in this case would be all real numbers x such that x is not equal to -2. Hopefully you realize why that is, because we get a 0 in the denominator. Now I want to take that information and I want to put it onto the graph, and I want you to look at this graph. And if I drew the line x equals -2, I would get this vertical line, and I'll be darned, looks just like that's exactly where the vertical asymptote would be on that rational function. Kind of cool. Okay, take a look at number 2 here. It says 2x over x squared minus 9. Again, I'm going to go ahead and figure out what the domain is. I'm going to factor the denominator. That's the difference of 2 squares, so that's going to be x plus 3 times x minus 3. And then if I set this equal to 0, I can see that x can't be -3 or x can't be +3. So therefore, the domain is going to be all real numbers x such that x is not equal to plus or minus 3. Notice there are 2 values here. Well, if I take this information and I look on the graph, here's -3. I'll be darned, look at that. And here is +3. Holy cow, look at that. That's exactly where the vertical asymptotes are. I'm hoping that you're seeing something here. Hopefully you're shaking your head going, yeah, Mr. Jerry, I get it. Okay, number 3, on this side, check this one out. I have x squared plus 5x minus 14. Well, again, I want to factor this, if you can. So go ahead and factor it to x and x. Let's see here. The factors are probably of 14 are probably 2 and 7, right? And I need to make a positive 5 and a negative, so it's going to be x plus 7 times x minus 2. Go ahead and solve this for 0. So x plus 7 is worth 0, so x is going to be -7. X minus 2 is worth 0, so x is going to be worth 2. And looks like now I can identify the domain as all real numbers x such that x is not equal to -7 or 2. Holy cow, that's exactly where our vertical asymptotes are on this rational function. So I'm going to ask you to summarize what you are seeing in box number 2. Okay, box number 3, here's a you try. I want you to find the vertical asymptotes for this rational function. Okay, the solution is to factor the denominator of x squared plus 8x plus 15 into x plus 3 times x plus 5. Solve each of those for 0. You get x equals -3 and x equals -5. Therefore, the domain is all real numbers x such that x is not equal to -3 or -5. Thus, the vertical asymptotes will be located at the vertical lines x equals -3 and x equals -5. Boom.